Good afternoon, students. I'll start with the class. In the previous class, we had seen how to find equation of a line. So there were two types. That was one was vector form, and this was Cartesian form. Okay. So in order to find equation of a line, what are the two things you need always? That is, one is always one point. Okay, coordinates of a point, and the other one is the direction ratios. So if you know these two, you can always find equation of a line for both vector as well as Cartesian form. So point and direction ratios are required. So we have done three question number on page number 4. So question number 3A and 3B we have done. Now we'll be doing 3C. So what they've asked is find Cartesian equation, but we are finding both vector as well as Cartesian so that we get used to finding both the ways. Okay, for exam, if they specifically ask Cartesian, then you can find. But as of now, I'm finding both and keeping. So question number 3C, you have to find the equation of a line which is passing through the point has been given to you. 2, 3, 4 is the point, and what is in said that it is parallel to the x-axis. So already to find the equation of a line, we know the point, and parallel to x-axis means whatever the direction ratios of the x-axis will be direction ratios of this line. So of this line we have to find the equation. Okay. So parallel lines always have equal direction ratios. So what are the direction ratios of x-axis? Can anyone tell me? On the first page only I had given. What are the direction ratios of the x-axis?
One zero zero.
Yes, 1, 0, 0. If it was y-axis, then it would be 0, 1, 0. Okay. So now it is parallel. So we got the direction ratios. These are my direction ratios, which I always write on the line in terms of comma, no putting bracket. So whatever direction ratios of x-axis are direction ratio of this line also. So you don't have to find again. Okay, so this is the same thing. Now write the vector form. So vector equation is what? R bar. This is a formula. A bar plus lambda m bar. M bar means of the direction ratio. And this is the point. So what is the point? This. But since we are writing vector equation, we have to write it in the vector form. So first I, j and k plus lambda times m bar. M bar means of this we have to form 1 I cap 0 j cap plus 0 k cap. You can write like this also. Plus lambda times I, because this anyways will be 0. This or this both are correct. So this is a vector equation. Now we'll find Cartesian. Cartesian is, I told you, point you have to always write in the numerator, and directions you have to always write at the denominator. So x minus the point, that is 2, upon direction ratio 1 is equal to y minus 3 upon 0. then z minus 4. Even though it is not defined, it looks like, still you have to write because these are the direction ratios. So direction ratio is always at the denominator and point always at the numerator. So this is the Cartesian form of a line. If vector was not asked, only this much we have to do. Then question number, then D1. This is also similar to this, we can do. So D1, the point is given to you as 1, 2, 3. Okay. This is the line and it is given as parallel to the line. Okay. Point we already got. If nothing is there, it means it is 1 always. Point is there. Now we have to find direction ratios of this line. Direction ratios, I told you, is always at the denominator. But now if we have straight away written 3, 4, 1 as your direction ratios, your entire answer will be wrong. I'll tell you why. Because here you must have gone wrong. You have to, before writing direction ratios, make sure it is in the proper Cartesian form. X should always come first. Same way, Y should come first, not the numbers. We have studied like this, X minus X1. Then Y minus Y1. So Y should have been here first. So this is given ulta. If you want to make this reverse, you'll have to multiply numerator and denominator by minus. So that's how you will get like this. Y minus 3 upon minus 4. And Z minus 3 upon 1. So just make sure it is in the proper Cartesian form. And there should not be any coefficient also. Last class we had done. If there's a coefficient, we have to divide numerator and denominator by that number. And now your direction ratios are 3, minus 4, 1, which are same as this line also. So these are my direction ratios and this is my point. So now write the equation. So vector equation will be, so convert this in vector form, plus lambda times, convert this also in vector form. Minus means minus here. And Cartesian, want you can write a formula first. And then substitute x minus the point upon 3, y minus 2 upon minus 4, and z minus 3 upon 1. This will be your answer. Is there anyone who has not understood? Can ask. So given a point and parallel to any line, okay, now you know how to find the equation. Next one, fourth question. Find a vector equation of a line. Okay. Now this is called as conversion from vector to Cartesian and Cartesian to vector. Suppose you want to do. So this is this is the equation given to you. So they have given you Cartesian form. What they have said, write it in vector form. So whether whichever form you have asked, I told you what you need is a point and direction ratio. So find out what is the point and what are the direction ratios from this line. Okay, so it is in this form. Point will be always at the numerator. It will be 5. Okay, always opposite sign it will be. Minus means it will be plus. Now this is plus. So you have to take it as -4. And this will be normal 6. So the point is 5 comma -4 comma 6. And direction ratios will always be at the denominator. 3 comma 7 comma 2. And now write it in vector form. So just convert this into vectors and write the answer. That is 5 5 k. So this is the answer. So I converted Cartesian to vector. If it was given ulta, still you could find. Okay, suppose if they had given this equation, okay, and had asked you to find a Cartesian, so what you would do? If this equation was given, you can find a point. This is always the point, and these are always the direction ratios. So from this point, you would have gone reverse way. Point would have been here 5, -4 and 6, and direction ratios would have been 3, 7 and 2, and then you can write like this. So this is how you have to convert from Cartesian to vector and vector to Cartesian. The main thing is you have to locate the point and the direction ratios. Now fifth one, find the direction ratios of the line. Cartesian equation has been given to you. Whenever like this equal to is there, you should know that it is a Cartesian equation. So we have to find the direction ratios and vector equation. So before finding direction ratios, I told you bring this Cartesian in the standard form. Okay, you have to make sure x is always at the start, x, y, z, and there should not be any coefficient for x, y, and z. If it is there, then you have to divide. So now I'm not writing again. You know that internally numerator and denominator you have to divide by 6. So what it will look like? Same way, this you have to divide by 3. Okay, so this will be x minus 1 by 3. Now direction ratios are over here. I told you you can always reverse and write it like this also. And now to find the equation, I need the point also. Direction ratios I got. Where is the point? You will get at the numerator. This will be minus 1 by 3 because this is plus. And this will be plus. And now write the vector form. Vector form will be I, j, k here plus lambda times this I, j, k. That you write. Vector equation will be hence 1 minus 1 by 3 j k and plus k. Same way you have to do the B part. Question B. Nothing is there, take it as 1. Over there you'll have to divide by 4. Here divide by 3. Over here, see, two things. First of all, y is not this side. The z is not this side on the other side. So you'll have to divide by minus 2. Here you have to divide by 3. Here you have to divide by 4. Just because it's minus, to make it plus, I'll have to divide by minus 2. That time it will become ulta. This also will become minus 1 by 2. And then you write the direction ratio. So first it will be 1 by 4, comma 1 by 3, minus 1 by 2. Then reverse it, it will become 4, comma 3, comma minus 2. And point will be here. And write in this form vector equation.
Miss, y divided by minus 2.
Y, where is y? 1 second. Why y is divided by minus 2?
Z there.
Okay, here.
Divide by 2.
Yeah, no. See, it will look like this. Correct, it is. See, this, when you are dividing it by minus 2, it will look like this first. Like this. So what I have done is, straight away, I wrote it on the other side. Which is same as, when you minus and minus, this will become plus. So I have written that first. So Z, this and this will cancel. Then minus 2 upon this will be anyways become minus 1. So this I wrote next, and first I wrote plus, and it will be like. So finally we have the same answer. See, 2 and 2 will cancel, minus into minus will become plus. and this minus 1 will go here. Okay, and moving on to the sixth one. Find P so that the lines, there are two Cartesian equations which are given to you. So the two lines are at right angles, they have said. Okay. So whenever I told you any two lines are perpendicular, the relation between their direction ratios is always A1, A2, B1, B2 plus C1, C2 is equal to 0. This is the condition for perpendicular line. First direction ratio into the second line direction ratio. So that's why find direction ratios of both the lines. So which are the two lines given? The first line is 1 minus upon 3. Z minus 3 upon 2. So this you'll have to divide by minus 3. So minus means make it ulta. No, sorry, divide by minus 1. If you are making this reverse, this also will become reverse. This you'll have to anyways divide by 7. This time dividing by minus 1. This is okay. This is in the correct form. So y minus 14 upon 7 will become 2. Okay. And this will be straight away that. 14 upon 7 will be 2. And then denominator also I have divided by 7. Now these are my directions ratios of the first line. Now the second line, do the same way. Y minus 5 and 6. Over here, you'll have to divide by minus 7. So what it will become? X minus 1 upon minus 3 upon 7. Numerator and denominator, you have to divide by minus 7. So this will anyways reverse and it will become minus. This is in the correct form. This you'll have to divide by minus 1. So reverse z minus 6 upon minus 5. So A1, B1, C1, A2, B2, C2. So this into this, second into second, plus third into third is equal to 0. Then you'll get the value of P. So first into first, minus 3 into minus 3 by 7 plus 2 upon 7P into 1, 2 into minus 5 is equal to 0. If you want, you can write and keep on. This is A1, B1, C1, A2, B2, C2.
Miss that minus 3 by 7p.
Once again, I'll just say minus. There is P here. Yeah. Okay, now you calculate and then find the value. So this will be anyways 9 by 7 P, then 2 by 7 P minus 10. And you can take on the other side. 7 is common. So this will become 70. And P is 70 upon 11 is your answer. The last one, 7th one, find a direction cosines they have said. Okay, so I told you, even if you are asked to find direction cosines, first you'll have to find the direction ratios of a particular line. First we'll take, you know that whatever in terms of I, J and K is been given. So that's a vector equation of a line. J you put outside over here. 1 plus 6 lambda, then J will be out. Just correct it on the notes. So this is the question given to you. Okay, I have by mistake written it inside. Just write J out. Now, this is not the actual correct form vector equation. If you have noticed, in vector equation, it's always a point is separate and just one lambda is there, and then m bar. If you notice here, there are 3 lambdas. So you know that it is not a standard form of vector equation. So simply I cannot say this is my point and this is something. So what you have to do is bring it in the standard form. We'll separate out the point and we'll separate out the direction ratios. So open up the bracket. Later on you can reduce the steps. Okay, first time now I'm teaching you, so I'll use all the steps. I will get multiplied here also, 3 lambda. Like same way, J you multiply inside to both the terms, and then K. Now bring those terms together which does not have lambda with it. So lambda terms you take one side and pure terms you bring one side. This is 2I cap, J cap, and minus 5K. I brought this terms together. Why? Because it does not have lambda with it. So that's the point one. And lambda ones, take it on the other side. And now take lambda common. So you can reduce the step, and while doing this only you can write lambda out. Okay, whenever next some problem, if this type comes, I want to adjust this in the standard form, straight away you can reduce this step and write lambda out. So now it is in the standard form. So this is the point now, and whatever is there with lambda is the direction ratio. So you got your direction ratios. Okay, so see if you can simplify this further. No, you cannot simplify. And now direction cosine. Cosine means I told you we just have to divide by root of that. And that's the answer. Just calculate and write.
7, 6/7, and 2/7.
Okay, this is turning out to be 49.
7.
Okay, so that those are your direction cosine. 3/7, 2/7. Okay, now we'll move on to the next type of problem. Remember, in college, I will not do this type separately. They will all do this mix. So that's why I've given it under like foot of a perpendicular made subtopics. Otherwise, this chapter becomes a complete mess. So try to understand concept wise, not to by heart the problems and go. Foot of the perpendicular. So whenever two lines are perpendicular to each other, okay, this is always the foot. Okay, this one. We'll start straight away with the first question. Find the foot of the perpendicular. Whenever they say find foot of the perpendicular means what? You have to find point B in short. You have to find the coordinates of that point B. So find foot of the perpendicular and the length. Okay, length means later you'll have to find a distance. That's fine. Main thing is you have to find the coordinates of this particular point. Okay, so now the first is it is drawn from a point. So this is the foot of the perpendicular drawn from a point means always this point they will mention. Okay, this is 0, 2 and 3 which is they have given. Now we have to find this point and to which line they have drawn it is that equation of that line is given. You can mark it as C and D. And that equation of this particular line is, write it on that line. So this is what the data has been given to you. Okay, so this is the concept from where it starts. You have to find an arbitrary point. Means what? We'll have to find this some point at least. Okay, whenever it is. So you have to find this arbitrary point B. Arbitrary means in general. Okay, a general point because you don't know what are the actual coordinates. The first step is to find step 1, find arbitrary point B. I don't think so. You'll remember. I told you all how to find an arbitrary point. I'll teach you again. So whenever they give you Cartesian, so I told you not necessarily they might give you lambda at the side or not. So even if they don't give lambda, you just can mention it over there while finding the arbitrary point. You need that compulsorily equal to lambda at the end. Okay, over here, just write it like this equal to lambda. Here, like this. Okay, so equal to lambda. Now, in short, I have to find the value of x, y, and z. Okay. Now, first time I'm teaching you the long method. Later, you have to do the shortcut method only. You cannot waste time in calculating. So every time, just take one at a time. X plus 3 upon 5. I'll write here only. So you have to take one at a time. First part equal to lambda. Then find a value of x. So what will so x is 5 lambda minus 3. Same way, equate y. The second part to lambda. The same way you'll get this value. And the last one, z, equate z. So that way you'll get a value of x, y, and z. So next time onwards, you have to calculate this in your mind itself. See, you have to just look over here and we have to say what is the value of x, 5 lambda, and if you go take it on the other side, it will become 5 lambda minus 3. Same way, 2 lambda plus 1, 3 lambda minus 4. So I've given this just in case if you forget. Then the third one like this. Z is 3 lambda minus 4. So put it in the arbitrary point form. So x value, just put it. Y value. Now you have to put a bracket because they are the coordinates. So this is my arbitrary point B. Anyone having doubt in finding arbitrary point, please ask. Okay. This is the first part which has been done. So that 0, 2, and 3. Okay. If you want, you can write it on the diagram also in case you don't have space, leave it. So this is one point, this is my second point. Now my next step is to find the direction. I know what are the direction ratios of line CD. Direction ratios of line CD will be here. See, 5, 2, 3. Okay, are the direction ratios of line CD. Both the lines direction ratios I need. So CD's line will be here. So 5, 2, 3. Same way I have to find now next direction ratios of line AB because they are perpendicular. Okay, so I have to multiply them, both the direction ratios. So the Cartesian equation, I don't know of this where I can locate, but I've told you if you know the points, okay, starting only I told you, if you know A and B, okay, point A, point B, you can always find the direction ratios how x2 minus x1, y2 minus y1, and z2 minus z1. So using that concept, what you can do is, this you can consider as x1, y1, z1. This will be x2, y2, z. The 2 points you know of a line. So straight away you can find direction ratios by minusing x2 minus x1, y2 minus y1, and z2 minus z1. I'll just write in. Later you can skip this. Okay. So 5 lambda minus 0. Same way 2 lambda plus 1 minus 2 and 3 lambda minus 4 minus. Calculate what are the direction ratios. 5 lambda minus 3. These two steps can be skipped. Straight away you have to calculate this in your mind and write. These are my direction ratios of line AB. And these are of CD. So I told you any time two lines are perpendicular, you know that A1, A2, B1, B2, C1, C2 will be equal to 0. Okay, so I'll write here on top. Okay. So what was this? I'm just writing for my reference. CD was what? 5, 2, 3. AB is this. Order will not matter. Okay. Whether you do A2 into A1 or A1 into A2. So this into this into this into this, it will be equal to 0. CD and AB's direction ratios you have to multiply. Therefore, 5 into 2 into 2 lambda minus 1 plus 3 into 3 lambda minus 7 equal to 0. Now open up the bracket and solve. We'll get the value of lambda.
Miss,
Yes.
what years of line AB?
Hmm? What?
DRs of line AB from that
DRs of what you're asking? Line AB.
AB, AB.
How you got? How I got? Are you asking?
Yes, miss.
Okay, I told you. Whenever you know 2 points of a line, we have studied on page number 2 only. I had given you this concept. Whenever you know 2 points, there are too many ways to find direction ratios. One is straight away if you have a Cartesian form, that is like this, or they might give you directly a vector. Vector means you just have to find. Now the third one more method was, if you know any 2 points, then you can do x2 minus x1, y2 minus y1, z2 minus z1. Find this vector. Okay. So the direction ratios is x2 minus x1. Now these 2 points I know, I want to find direction ratio of this line. So this minus this. So 5 lambda minus 3 minus 0 is this. Then 2 lambda 1 minus 2, I'll get it as minus 1. This part I think I have not copied before. This what I have done. Then 3 lambda minus 4 minus 3 will be 3 lambda minus 7. Understood?
Yes.
Okay. So if you want, you can write always on the line and keep also. These are the direction ratios.
Lambda is equal to 1.
Okay. So these are the direction ratios of this line. These are the direction ratios of this line. From here I got. Now I have multiplied this into this, this into this, this into this, because for perpendicular it follows that rule. Now after solving, you will get lambda is equal to 1. Open up the bracket, 15 lambda, then bring all the lambdas together, numbers together, and then calculate. So the moment you get lambda, now you have to substitute and find a point. So what was your B? So now we'll find a point B. What was that arbitrary point B given to you? 5 lambda minus 3, 2 lambda plus 1, 3 lambda minus 4. So put the value of lambda here, you'll get the point. So you got the foot of the perpendicular. The first part is done. Anyone has not understood this? Just find the value of lambda, put it back here. So you get a point B. So this is what you have now. 0, 2, 3 is A, and now got B. 2, 3, and minus 1. After calculating, lambda as 1. first part is over, and second part what they have said, length of the perpendicular. Length of the perpendicular means length AB. So use the distance formula. Distance formula is x2 minus x1 the whole square, y2 minus y1 the whole square, plus z2 minus z1 the whole square. So A is what? x1, y1, z1. B is x2, y2, z2. And write units for that at the end. Centimeters, this meters is not specified. You have to write units. So x2 minus x1. Whichever way you also do, no? This minus this also still you'll get same answer. Why? Because it's finally squaring it. So minus also if you get, still squaring will give you plus. So whichever way you want to minus, no problem. So 4 plus 1 plus 16 root 21 again. That's your length. Okay, even now if some doubts are there in the first one, we'll do the second one, similar one. Now here also if you're struggling, then you please get it clear. So this is 1 comma 2 comma 3, and this line is which is equal to lambda. Coincidence it became like steps. We all don't write in steps. It's a straight line, huh? Just trying to adjust it there. So B is the arbitrary point on the foot of the perpendicular. Okay, so this is the data. So always find the arbitrary point first. Now I told you, you have to follow the shortcut method. In the mind, equate this to lambda. So what it will be? 3 lambda and minus 6 will go on the other side. It will become plus 6. Straight away. Okay, no need to write what is x, y, and z. And like this straight away you have to find the arbitrary point. Then I want to find a value of y. So 2 lambda plus 7. And the third one, minus 2 lambda plus 7. This first step is your arbitrary point. Want to write here? You can write. So this is my point A and this is my point B. After arbitrary point, we have to find the direction, the ratios of both the lines. Whichever way you want first, okay? So this is easily available. So we'll write of CD first. Direction, the ratios of line CD is over here. Look it over here. 3, comma, 2, comma, minus 2. Now you have to find direction ratios of line AB. There are no Cartesian equations. I told you 2 points you know. So the concept goes as those were not written last time. X2 minus x1, y2 minus y1, z2 minus z. This is always x1, y1, z1, x2, y2, z. So second point minus this. So straight away again calculate in your mind only and write the answer. 3 lambda plus 6 minus 1. No putting round bracket, it will be wrong. Then 2 lambda plus 7 minus 2 plus 5. And minus 2 lambda plus 7 minus 3 will be plus 4. So these are your directional ratios of line AB. So first step, repeating again, find the arbitrary point, then find direction ratios of both the lines. Whether you want to do this first, this doesn't matter. I want direction ratio of both the lines. And now you know that both lines are perpendicular. Now no need to write that formula A1, A2 and all. They don't expect. You can straight away multiply. So first into this, so 3 into 3 lambda plus 5 plus 2 into 2 lambda plus 5 minus 2 into minus 2 lambda plus 4 is equal to 0. Now open up the bracket, calculate, find the value of lambda.
Lambda is equal to -1.
Okay. And then you put it over here and find the point B. Minus therefore 17 lambda is equal to minus 17. Lambda will be minus. And now put minus 1 over here. Minus 3 plus 6. 5 plus 9. So you got your answer. Put of the perpendicular. And then find length AB using distance formula if they have asked to find the length. Now only find the yeah, correct. Root of the perpendicular and the length drawn. So find length also. So length you know simple. A is 1, 2, 3. B is 3, 5, 9. So this is my one answer. The second part is this. 3 minus 1 the whole square. 5 minus 2 the whole square will be 4.
7 units.
Yes, that will be 49. 7. Anyone having doubts in this? We move on to the third one. It's slightly different. When they don't give you a Cartesian equation, instead they give you 2 points. B and C is given there, no? Okay. Okay, just write the third point as C, okay? C, then bracket. So now they have given like this. 1, okay, the other line which it is joining is this 2 points. The line, okay, this is a line which is perpendicular to a line which is joining the 2 points. B is this they have given, and C is this 5, 4, 4. Okay, now if they have given specifically some letters, then you can take any other letter over here. So now D is the foot of the perpendicular. Okay, earlier if they don't mention any letters, usually we take A, B. Now they have specified, that's why we cannot take B here. Now you can take this letter as D. No, whenever they give you points, first of all, to find with our first step was what, to find the arbitrary point D now. But to find arbitrary point, is there a Cartesian equation? No. So our first step is now will be to find a Cartesian equation, so that we equate it to lambda and then find the arbitrary point. So I told you, anytime you want to find Cartesian equation or vector equation, doesn't matter. We need one point and the direction ratios. So can always find. So what are the direction ratios of line BC? Can anyone tell me how to find direction ratios of line BC?
B
I know that.
minus A.
Huh? B minus.
B minus A.
Where A came? B minus A is here. Triangle it became. I want of BC.
B minus
Huh.
C minus B.
Yeah, C minus. I want direction ratios of this line, correct? Because I want to find equation of this line. BC means what? C minus B. So this is x1, y1, this. So it will be always the second point minus the first point. So 5 minus 1, then 4 minus 4, and 4 minus 6. So the direction ratios you can write here also on the line and keep. So that's 4, 0, minus 2. You don't even have to show this. Straight away you can write on the line. Direction ratios is 5 minus 1, that is 4, 4 minus 4, that is 0, and 4 minus 6, that is minus 2. So these are my direction ratios, and this is my first point. Okay, this is the point, and this is the direction ratio. Always take the first point while finding the Cartesian equation. So how to find a Cartesian equation? Always x minus the point, that is 1, upon its corresponding direction ratio. Then y minus the point upon the z minus z coordinate upon equals to lambda. So you got your Cartesian equation. Anyone who has not understood how to find a Cartesian equation? First find the direction ratios, You know the point, you know the direction ratio. So straight away substitute. Point will always come at the numerator and direction ratio will always come at the denominator. Now you know the Cartesian equation. Find the arbitrary point D now. This foot of the perpendicular. So what it will be? Multiply 4 lambda plus 1. 0 lambda will be anyway 0. Still you want to write and write plus 4. And the third will be minus 2 lambda plus 6. So this is the arbitrary point. A is given, no? So you got arbitrary point now. You already know the direction ratios of line BC. Now which are the two lines perpendicular, AD and BC? No, BC already I got. Now find direction ratios of line AD. Again same way. Second point minus first point. Second point is this. You want to write here and write in C. Otherwise straight away we can do from here on. This minus this minus this. First, second step, third. So basically what I need is one arbitrary point and the direction ratios of both the perpendicular lines. So BC is done, no? So now AD. So 4 lambda plus 1 minus 1 will be just 4 lambda. Then 0 lambda and with plus 4 minus 2. Okay, so that will be minus, sorry, plane 2. And then minus 2 lambda plus 5 you will get. 6 minus 1 will be 5. And now multiply this into this, this into this, this into this will get a value of lambda. Whichever AD is perpendicular to BC. A1, A2, B1, B2, C1, C2 equal to 0. How much are getting lambda?
Half.
Okay, then find that point. Point D you'll have to find now. Huh? So what was D over here? Just put lambda. This you can calculate in the rough work column also and substitute straight away. And it will not matter. So that will be 2, 3, 4, 5. And then you know how to find the distance. Then find length AD. So that is up 3 minus 1, 4 minus 2, and 5 minus 4 plus 4, 24, I think. Root 24 it will. Root 24 units. So these are the two ways which it can be asked. One, where they will directly give you the Cartesian equation, or else they will give you the 2 points. Then you have to find the Cartesian equation and then the arbitrary. Now that page 5, question number 2 is also same way. Only thing last, instead of finding the length, we'll have to find the equation. Otherwise everything is same. So just you can do similar to this concept only. Only finding equation part I'll tell you last. So everything else same method. Find a foot of the perpendicular. Okay, find point D. Also find a length also they've said. So other than length, one more equation also will have to find of this line. Only that extra part I'll teach you. Otherwise everything is same. To start, first draw the diagram. Same like this only. B and C will come here. This you can mark D. Don't wait to copy, just try to solve on your own so you'll know where you're going wrong or if you're getting stuck somewhere. And if you have understood, you must have realized there's nothing to by heart in this. It's all about logic. You just need to know what all you need. It's definitely understood. First you need arbitrary point, then you need direction ratio because they are perpendicular. And these are all the questions from the question papers. Huh? If your notebook is complete from the start, all the question paper solutions will be there in your notebook. Okay, so first what you need to do is find the direction ratios. So 3 minus 4, 5 minus 7, 3. Okay, want to later while studying want to know how it came. It's like so that's minus 1. This is first part done. Now find the Cartesian equation of this line. So this is the point and these are the direction ratios. The Cartesian equation is nothing but x minus 4 upon minus 1, y minus, at least by now you should know how to find Cartesian equation. Huh? And z minus 1 upon is equal to lambda. Then find the arbitrary point D. It will be minus 1 into lambda is minus lambda plus 4 minus 2 lambda if this anyone having doubt how to find arbitrary point can ask, I can repeat. Ensure you have to find a value of x y and z. Put the value of x here, y here, z. Okay. Find the direction ratios of line AD. AD will be what? This will come here. This minus this. First, second minus second, third minus plus 3 was 4 minus 1. Then this and this line is perpendicular. So first into first, second into second, third into third. Whichever way you write doesn't matter. BC is perpendicular to AD. Or AD is perpendicular to BC. So minus 1 into this, into this, and then equate it to 0 and tell me the value of lambda. Anyone has got the value of lambda?
Seven by three.
How much?
7 by 3.
7 by 3 you're getting. Okay. Yeah. Then substitute, find a point D. So substitute a value in the arbitrary point, find a value of D. So D is this. Well, so 5 by 3 minus 14 plus 21 and this will be your answer. 14 and then cross multiply 14 plus 3 upon. So that's your point D. Then you can find the length. Last we'll find the equation. first cross multiply and then square. So this will be 5 minus 3, 2 by 3 the whole square. This is anyway 7 by 3 the whole square. And this will be 17 minus 9. Okay. 8. And now square. 4 by 9, 49 by 9, and
Square root of 117 by 3.
yes, because root 9 will anyways become 3 and come out. So it will be answer. So this the last part, that is they have extra asked to find the equation of the perpendicular. Length we have already found of the perpendicular. Now what we have to do is find, here only it is, this is a line. Okay. You have to find equation of line AD. Now I told you, in order to find which equation they have not mentioned, so anyways we'll find both and keep. Okay, Cartesian as well as vector. To find equation, I need 1 point. 1 point means the first point always. First point I already got, and the direction ratios. You know how to find the direction ratios. This minus this, this minus this, this minus this. The direction ratios of AD will be 5 by 3 minus 1, 7 by 3 minus 0, 17 by 3. So cross multiply. So these are your direction ratios. And the point is what? So you know the point, you know the direction ratios. Find the equation. So we'll find vector equation. Both will find it. It won't take time. Okay, just one step. The best option is to write both and point vector will be 1 I cap. Even if you skip J part, no problem. M bar means of the direction ratio vector. I cap, sorry. 7 by 3 J cap plus 8 by 3 K. Want to find a Cartesian? Then that minus point upon the direction ratio. X minus the point upon the direction ratio. Y minus 0 upon second direction ratio. Z minus the third point upon the third direction. So this is the only extra part if they ask you to find equation. If they are just find foot of the perpendicular and the length, that would be over. Only if they ask you to find equation, that extra you have to find direction ratios and write both the equations and keep. Now this will get reversed, 3 will go up. Finally, if you want to simplify, right, it will look like this. 3 will go up and get multiplied. 3y minus 0 is anyways not counted. Or you could even simplify it. Wait. No? That's common thing, no? Wait. You could have just multiplied throughout by 3. I told you can always simplify. The direction ratios will be 2, 7, 8. Everywhere you can just cancel this 3 common. Ratios can be simplified. The answer is this one. Put 3. Cancel that. 3 is common everywhere. That's why you could cancel. If one of this was 2 like this, you can't do that. If one of them was 2, then you have to do that multiplication volta. So these are the direction ratios, the final one, and which I put here. Okay, I'll stop here. That B1 you do same way, same as A only. Okay, so that's all this. C1 I'll do next time in the next class. B is for your work.